All right. So now we just did a whole bunch of binomials. This time, what's happening is you have a binomial times a trinomial. So what happens then, and this is really, you guys, where I think the box method is more effective because it helps you keep things in order. You absolutely can do FOIL, or I should in this case call it the distribution process, because technically you have a middle term, so it's not just like firsts and lasts. For the rest of these, will probably be using the box method just to keep things, like I said, organized and in place. But if you are gung-ho that like you absolutely want to do the distribution method, aka FOIL, that is totally your call. I just am going to do it this way to keep things organized. So for these, I've got x squared, there's 5x and 8. And then we've got x plus 1. Now, just as a heads up, you do not need to set this up this way. You could set up more of like a rectangular box like this if you wanted to. Hopefully yours is a little bit better than that one because that's not a good one. But if you want to set up more of a vertical rectangle instead of a horizontal one, again, it doesn't matter. It is all your preference. Whatever you have that works best. It's very versatile. Okay, so last one. We're going to multiply these two together, so that's going to be x squared. Now we're going to take the 5x and the x and multiply those together. That's going to go in the top middle box. So that would be 5x squared, and I just noticed I made an error. That's what you get for going fast, because that should be x cubed, not x squared. And then the upper right-hand box, that turns into 8x. Then if I go to the bottom, then there's x squared. Again, you guys look diagonal. X squared, 5x squared, and x squared, they're diagonal. I really like this method. I think it works really well. And then you've got 5x, and then you've got 8. So make sure you go from there. You combine your like terms. So there are your x squared terms. Then you've got more terms that are like, so you're going to have to look diagonally twice. But simplifying, that would be x cubed, and then you have 6x squared. Let's see, these are all positive, so that would be 13. Yeah, 13. And then plus 8. Again, you guys, if you chose to do the distribution method, that'll work. You came up with the exact same thing. Pick your method, go with it, and just rock it like the all-stars you guys are. Okay, so last one like this, and then we'll do the word problem. So I'm going to do n minus 3, and then I've got n squared minus 2n plus 4. Okay, now I'm going to encourage you guys, really watch your signs because you've got some subtraction / negative signs in there. Right, you've got a negative, another negative, then you got a positive. So your signs are going to be switching up just a little bit. So something to pay attention to. All right, so again, we start off, we get n cubed. You're taking n squared times n. And then you're going to have negative 2n squared. And then 4n. Now going down to the bottom, so you've got negative 3n squared. Then you're going to the middle, that's going to be 6n. And then off on the right-hand side, negative 12. Again, just identifying those like terms. They are diagonal from each other. So find them. Combine them. So that's n cubed. Then you've got negative 5n squared plus 10n. And then minus 12. So there are those examples. So I know those are the only examples of those type. Let's see. So if you want to try 9 and 10, just for a little bit of extra practice, if you notice the signs, they keep the signs exactly the same as the last couple. So if that's something you struggled with, even just kind of taking a look there. Take a minute, pause the video, try them. If you've got questions, bring them in, let me know. I'm more than happy to go through whatever you need me to with you tomorrow. Okay. Now, since we've got the state hockey tournament going on right now, why not have an example that deals with hockey, huh? All right. So, in hockey, a goalie behind the goal line can only play a puck in the trapezoid region. I didn't realize I still had the highlighter on. In the trapezoid region. Okay, so we're looking at a trapezoid. So this right here. And I do believe you guys have this picture on your note packets. I'm pretty sure I remember to put this one on there. Okay, so first thing, write a polynomial that represents the area of the trapezoid region. So that's going to require us to tap into like finding area of different shapes. So the area of a trapezoid, and maybe you know this formula, maybe you don't, but if you don't, get this written down. Because the formula for area of a trapezoid is 1/2. Then you're going to take that 1/2 times the height. And then you're going to have the sum of the two bases. And you're going to take that entire thing. So it's kind of a different formula. But like if you look on the picture here, you would say that this is base, and you can call it base 1, call it base 2 if you want to. And that would be your other base, and then this right here would be your height. So essentially what you're doing is you're just taking those couple of pieces and you're plugging them in. So 1/2, your height is x minus 7. And then your first base is just x. And then your second base is x plus 10. So from there, you're kind of just, again, doing a whole bunch of multiplying together, foiling. Again, should call it the distribution method. But what I'm going to do is I'm just going to, since I don't have enough room to do the box method, I am just going to do the distribution method. So I'm going to start by distributing this 1/2 through. So that's going to be 1/2 x, and then that's going to be minus 7/2. I'm just going to put a parenthesis around those, and then I'm going to simplify this stuff inside of here. Notice how you've got 2 of those x's, plus 10. Now, this next part looks intimidating and it looks super scary, but it's actually not, because you've got multiples of each other. So if you look here at the firsts, you have 1/2 and 2. Those just end up canceling each other out. So you end up with x squared. Don't forget about that squared because you've got 2 x's that you're multiplying together. And then you're going to the outsides. Again, if you take half of 10, hopefully you guys are able to calculate that pretty quickly mentally. So that would be 5x. And then if we go to the insides, so once again, you've got 2 and you've got 2 in the denominator there. So those 2's are essentially going to cancel each other out. Just make sure that you watch the negative there. So that'd be negative 7x. And then your lasts. So you're taking that negative 7/2 times 10. So multiply the numerators, that's 70. And then divide it by 2, that's 35. So you end up with a negative 35. Combine those like terms really quick. So x squared minus 2x minus 35. And that is the polynomial that represents the region. And then for part B, it says find the area of the trapezoid when the shorter base is 18 feet. Okay, so they basically just want you guys to take, so notice how the shorter base, that top base right there, is just x. They just want you to plug 18 in for x. So they make it sound more intimidating than it actually is. So really you're just taking 18. So 18 squared minus 2 times 18. So I'm just taking this polynomial up here and I'm plugging 18 in wherever applicable. So then, let's see, if we take 18 squared, that gives you 324. 2 times 18 is 36. And then minus 35. So if we just combine all of those, 324 minus 36 minus 35, 253. So 253 feet, and this one actually is squared. And that's a weird looking too. I'm just going to erase that. Okay, 253 feet squared. Okay, that's all I got for you for these videos. So hopefully this went well. If you've got questions, let me know. Otherwise, tomorrow, again, we'll work on the assignment and just kind of get you into spring break pretty painlessly. All right, we'll see you guys tomorrow. Have a good rest of your night.